So let's talk about something bigger than just building an app that works today. We're talking about building an app that's still easy to work with, still scalable, and still maintainable years down the road. That's the real challenge, right? And clean architecture is the answer. In this explainer, we're going to break down exactly how it works.
We've all been there. An app comes out, it's fast, it's clean, you love using it, but then a year goes by, a few dozen updates later, and it just feels clunky. New features somehow bring back old bugs. So why does this happen? It's not usually a single line of bad code. Nope. It's a breakdown in the app's fundamental structure, its architecture.
To really appreciate just how elegant a clean solution is, we've got to get our hands a little dirty. We need to look at how things used to be done and really dissect what makes an old legacy app tick, or more often, what makes it break. Okay, I want you to picture a ball of yarn after a cat's had a field day with it. That's pretty much what a legacy app's architecture looks like. It's a mess. The UI code is all tangled up with the business logic. The networking code is wrapped around the database code. Everything is connected to everything else. In a real app, this means your main screen might be directly calling a specific networking library, which then depends on a very specific data format. And that tight coupling, that's where all the problems start. And this tangled mess leads to a bunch of questions that every developer dreads, like, how in the world do you test your business logic when it's stuck inside an Android activity? Or what happens when you need to add a simple feature like caching? Do you have to rewrite half the app? What if you want to swap out your networking library? See, these aren't just annoying tech problems, they're real business problems that slow everything down to a crawl. So, how do we start to untangle this knot? Well, it doesn't begin with some fancy new tool or a library. It starts with a philosophy, a set of really solid, timeless principles for writing better software. These principles came from the mind of Robert C. Martin, who you probably know as Uncle Bob. And what's so important here is that these ideas aren't specific to Android at all. They're fundamental truths of good design, and they give us a clear roadmap to get away from that tangled mess we were just talking about. Now, this slide breaks down the solid principles, and yeah, they might seem a little academic at first glance, but trust me, they all share one primary goal: decoupling your code. Take single responsibility. It basically means a class that draws a button on the screen should not also be in charge of fetching data from the internet. Or look at the last one, dependency inversion. It tells us to rely on general contracts or abstractions, not on specific libraries like Retrofit or Room. Every single one of these is a tool to help us build clean, independent boundaries in our code. And here's the real kicker. This way of thinking scales up. You start by applying solid to your individual classes, sure. But that same philosophy applies to how you group all those classes into bigger modules. The goal is always the same, whether you're looking at one file or the entire project. You want to create independent, reusable, and stable components that you can assemble just like building blocks. Okay, having the right philosophy is great, but you can't build a house with just a blueprint, right? You need tools. And this is where the Android platform itself has come a really long way. The official toolkit has changed so much, making it way easier to actually implement these clean architecture ideas. I mean, just think about the evolution we've seen here. We started with tools like AsyncTask, which, let's be honest, almost encouraged you to write that tangled, leaky code we talked about. But look at where we are now. Kotlin gave us a much safer language. Then we got architecture components with things like ViewModel, which are literally designed to help us separate our UI from our logic. And today, coroutines and flows have completely changed the game for background tasks, making it easier than ever to write clean, decoupled code. This slide just sums up that shift perfectly. On the left, you've got the old way, AsyncTask, which held a direct link to the UI, creating that exact tight coupling we want to avoid. But on the right, modern coroutines, while they're smart, they're lifecycle aware. This means they're tied to the life of your data, not your UI. So if the user navigates away, the work just gets canceled automatically. We've moved from a manual, error-prone process to one that's safe and automated. So we have the philosophy, solid, and we have the modern toolkit. Now we can finally put them all together to build a solution, a blueprint for creating clean, robust applications that are built to last. This is the big idea, the whole concept in a nutshell. I want you to picture an onion. At the very center, the heart of the onion, is your most precious, stable code, your business logic. On the outside are all the changing details, the UI framework, the database you're using, your networking client. And the golden rule, the only rule that really matters, dependencies can only point inwards. That's it. Outer layers can know about inner layers, but never the other way around. Let's walk through these layers with a quick example. At the very center, you have an entity.
let's say a simple user object with just a name and an email. The next layer out is the use case, which defines an action, like get user profile. One layer further out, an adapter, like a view model calls that use case and gets the user object ready for the screen. And finally, on the very outside is the frameworks layer, your Jetpack Compose UI, which does one simple job: display the data. Each layer has its own clear responsibility. This quote just nails the why. Why do we do all this? Because your core business rules, your entities and use cases should have zero knowledge of the Android framework. They shouldn't know or care what database you're using. They shouldn't care how you make network calls. Those are just details. And by keeping them separate, you protect your most important logic from change. And this is the before and after. Remember that tangled ball of yarn from the beginning? It's gone. We've replaced that total chaos with this clean, disciplined, one-way flow of dependencies. The UI can change, the database can be swapped out, but the core of your application, that precious business logic, remains untouched, stable, and protected. So what's the payoff for all of this work? What do you actually get? Well, you get an app that's just better in every way. It's profoundly adaptable. It's testable because your core logic is just pure Kotlin with no messy Android stuff to deal with. It's maintainable because changes are isolated to their own layers. And it's scalable because you can add new features without being terrified of breaking the whole system. You've built an app to last. And ultimately, this is the question that clean architecture forces you to answer. Are we building something disposable, a tangled knot that we know we'll have to rewrite in 2 years? Or are we building a solid foundation with clean boundaries and stable logic that can evolve and thrive for years and years to come? The choice is ours to make.